Good morning, students. So now we're on practice problems again. So try the practice problems by yourself, and then come and watch this video as usual. All right. So for this first one, what they want you to do is to basically take these equations and see if you can match them up to the ones on the right. So we're going to go through each individual one and kind of just do a little quick simplification for them. All right. So for A, what we can do, you got 3x plus 6 equals 4x plus 7. We can just simply subtract 7 from both sides of the equation. And you'll notice how I put the numbers underneath the numbers, and I'll put x's underneath x's. So kind of keep them in line. It'll help you to solve these. And when you do that, you'll have a 3x, and 6 minus 7 is your minus 1. And on this other side, the only thing that's left over is the 4x. So that first one transfers over to here to this one right here. So 3x minus 4. So letter A maps to number 4. Right? And your second one here, right, what we're going to do is we're going to go and use the distribution property, and we're going to go and distribute 3 over addition subtraction right here. So we'll get 3x plus 18 equals 4x plus 7. And then at that point, we go and start looking over on the other side. And so it transfers and maps right over to this one. It's exactly what we've been getting so far. All right. So letter B maps over to number 2, and then on C we have this one. So we have 4x plus 3x. That just simply, we combine like terms. Those things are the same terms. We can add them, and then 7 minus 6. We can simply do the math and get the 7x minus 1, which maps to number 5. So there's your solutions for this. I'll move my little face out of the way here. There we go. So A maps to number 4, B maps to number 2, and C maps to number 5. All right. Moving on to number 2. I says the equations A and B have the same solution. So here's equation A, here's equation B. A good way to figure out if you can go from A to B, how we can do this, well, realize that it's 3 times this quantity. So these things are being multiplied together. Therefore, I can divide both sides by a negative 3. And when I divide by a negative 3, 24 divided by a negative 3 gives you a negative 8. So the only thing left on this side is x plus 7 equaling a negative 8. So which statement makes this true? Well, it says adding 3 to both sides. We didn't add 3 to both sides. If anything, 3 is being multiplied. I'd have to undo it with division. Applying the distributive property? No, we did not use the distributive property. If I did that, I'd get negative 3x minus 21. Subtracting 3 from both sides. Again, I am multiplying. I don't undo multiplication with subtraction. I have to undo it with division. That gives you your last one there. Divide both sides of the equations by negative 3, giving you this. So delta is your correct answer there. All right. On to number 3. Is 0 a solution for this? Well, if we just go and substitute in 0, that's 2 times 0 plus 10 equals 4 times 0 plus 10. Well, that becomes a 0. That becomes a 0. So 10 equals 10. And yes, 0 is a solution for this particular problem. So it's pretty straightforward. Let's move on to number 4 here. Kieran says the solution to the equation x plus 4 equals 20 must also be a solution to the equation of 5 times the quantity x plus 4 equals 100. Well, let's look at this. What's the big difference between these two? Well, you have an x plus 4 in both of them, but I multiplied this one by 5. Well, if I took that and I multiplied it by 5 on this side, then I could multiply this thing by 5. And yes, you'll have the exact same solutions. Okay? So if you go through this one, the solution was 16. And then if you go through this second one, you'll still get the correct solution. So it didn't change anything. That's the idea behind manipulations of this stuff. Number 5, the Entrepreneurship Club is ordering potted plants from all 36 of its sponsors. One store charges $8.50 for each plant, plus delivery fee at $20. The equation 320 equals x plus 750 times 36 represents the cost of ordering from a second store. So this one isn't really written for understanding, you basically have two places to get the plants at. You're going to get 36 plants in each case. The things that change are your store charges of $8.50 or $7.50 per plant, and you have a delivery fee of $20 in one, and then we'd have to go through and find the X value for this one to find the delivery fee for the other one. Right? So that's what this B is. What's the X represent right here? Well, that's the delivery fee for the second store. And moving on. Number 6. Which equation is equivalent to this? Well, if you kind of look at these things, all right, if one's correct, then the other ones have to be wrong. Okay, so if you look at this one and then you go over to here to this one, what do they do? Well, they try to add 5x and 30. They're not like terms. You can't just add them. Okay, so this is not a true statement. The 35 there is the thing that screwed this thing up. Okay, so that one's out. 5x equals 75. Well, it looks like they're trying to move the 30 over to this other side. So to do that, you have to subtract 30, not add 30. And if you have 45 minus 30, it would be 15. So that one's completely jacked up. So no, that one won't work. This one, they factored out a 5, it looks like. And I can take a 5 out of here. 5 goes into 5x x times. 5 goes into 30 6 times. Well, they've neglected to take the 5 out of the second part here. So they didn't do the factoring part right. So that's why that one is screwed up. But if you look at these two, they're very similar, only this time they did in fact factor out 5 out of 30 correctly. So this last one, delta, that's your correct answer. All right. Number 7. The Environmental Science Club is printing t-shirts for its 15 members. The printing company charges a certain amount for each shirt, plus a setup fee for $20. Okay. If the total is $162, how much does the company charge per shirt? All right, so of the whole amount that you're going to be charged, $20 is for the setup fee, and then it's $15 per shirt times the number of shirts. So we have to solve for C in this instance. So we're going to subtract 20 from both sides. You get 142.50 on one side. The 20s cancel here, so I just got 15C. And since I'm solving for C, I divide by 15 because we're multiplying between C and 15, so we have to undo it by dividing. Divide both sides by 15, and you get your answer as $9.50 per shirt. Remember units. Number 8. The graph shows the relationship between temperature in degrees Celsius and temperature in degrees Fahrenheit. So down here you'll see Fahrenheit, up here you'll see Celsius. You can kind of look at this. This is 32 right here, which corresponds to 0 degrees Celsius. If you go up to 60 degrees, right here on 60 degrees Fahrenheit, that comes out to be about 16. We'll find out what it is in a little bit. And if you go all the way up to 140 degrees Fahrenheit, then you end up with 60 degrees Celsius. So let's see. Mark the point on the graph that shows the Celsius when it's 60. It's about 16 degrees. It's actually, in true form, it's 15.5 repeating Celsius. But they just want you to use the graph to find it in this case, not algebra. B, mark the point on the graph that shows the temperature of Fahrenheit when it's 60 degrees Celsius. So at 60 degrees Celsius, you come over and then you come down, and it's 140 degrees Celsius. Or excuse me, 140 degrees Fahrenheit. Water boils at 100 degrees Celsius. Use the graph to approximate the boiling temperature in Fahrenheit to confirm it. Well, if I went to 100 degrees Celsius, I follow along. There's the pot. Comes down to right at 212 degrees Fahrenheit for boiling water. The equation that converts Celsius to Fahrenheit used to calculate the temperature of Celsius when it's 60 degrees. This answer will be more exact than the point you found. So now we're going to put in the value of the Fahrenheit in here. It's 60. Alright, so we do the operations inside the grouping symbol first. 60 minus 32 is 28. And 28 times 5/9. And there's no common factors here. You can't really reduce this. You just have to do it on your calculator. And you end up with 15.5, and the 5 is repeating, degrees Celsius. All right. On to number 9. Select all the equations that have the same solution as this. Well, let's see. Let's find the solution for this thing. If I do that, I'm going to add 5 to both sides, so I'll get 2x equals 20. I then divide by 2, so x equals 10. So let's go through there. 2 times 10 is 10? No. 2 times 10 is 20. 20 equals 20. Yeah, so B works. 10 minus 5, that's 5. 5 times 2 is 10. Well, 10 is not equal to 15, so that one's out. 2 times 10 is 20. 20 minus 20 is, in fact, 0, so delta works. 4 times 10 is 40. 40 minus 10 is, in fact, 30, so echo works. And then here you got a little bit backwards here. So 2 times 10 is 20, and 5 minus 20 should be a negative 15, not a positive 15. So F is out as well. Number 10. Diego's age is 5 more than 2 times his sister's age. Okay. This solution is represented by the equation right here. So if you think about this, Diego's age is 5 more than 2 times his sister's age, S, which equation is equivalent to this equation. So they're asking us to take this equation that they give us and manipulate it. And the only one that looks even close is this one. What did they do to go from here to here? Well, they just simply subtracted 5 from each side. So that's how they got the 2s being all by itself and then d minus 5 right here. So that's how that works. And that is all for the practice problems. And we'll start with lesson 8 next.